Welcome to this session on Limits and Continuity Part 2. I'm Suman Matthews. You will learn a few more problems on continuity involving limits. So if fx equal to mod x, is this function continuous at x equal to 0? So we take limit as extending to 0 to the left of fx. Now mod x equal to x if x greater than 0, equal to 0 if x equal to 0, equal to minus x if x less than 0. So limit is extending to 0 to the left of mod x means x is less than 0. So mod x will be minus x. And when you substitute x as 0, the limit is 0. Limit is extending to 0 to the right of fx. Now when that is limit is extending to 0 to the right of mod x. Extending to 0 to the right means x is greater than 0. So mod x is x. So this is limit is extending to 0 of x, which is again 0. And f of 0 is 0 because mod 0 is 0. So we have limit is extending to 0 to the left of fx equal to limit is extending to 0 to the right of fx equal to f of 0. Hence, f is continuous at x equal to 0. Because for a function to be continuous at a point, the left-hand limit should be equal to the right-hand limit equal to f of that point. Question 2. Examine fx equal to x by mod x when x not equal to 0 for x equal to 0 for continuity at x equal to 0. So limit is extending to 0 to the right of fx will be limit is extending to 0 to the right of x by mod x. And mod x is x if x is greater than 0. So 0 to the right means mod x is x. So this is limit is extending to 0 of x by x, which is 1, because limit of a constant is the same number. Limit is extending to 0 to the left of fx will be limit is extending to 0 to the left of x by mod x. When x tends to 0 to the left, x is negative. So mod x is minus x. So it is limit is extending to 0, x by minus x is minus 1. So here the right hand limit is 1 and the left hand limit, that is limit is extending to 0 to the left of fx, is minus 1. So right hand limit is not equal to the left hand limit. So f is discontinuous at x equal to 0. Question 3. Fx equal to x squared minus 25 when x not equal to 5 equal to k when x equal to 5. Fx is continuous at x equal to 5. Find k. So we can factorize x squared minus 25 into x plus 5 into x minus 5. So x minus 5 cancels. So basically fx reduces to x plus 5 when x not equal to 5. So here we don't have a left hand limit or right hand limit. So we directly take limit as extending to 5 of fx. That is equal to f of 5 because f is continuous at x equal to 5. Because if f is continuous at x equal to a, limit as extending to a of fx equal to f of a. So here I have limit as extending to 5 of x plus 5 equal to k. Substituting the limit, we get 5 plus 5, that is 10 equal to k, or k equal to 10, and that is our answer. Question 4. Find k so that the function f defined by fx equal to kx plus 1 if x less than or equal to pi equal to cos x if x greater than pi is continuous at x equal to pi. So fx is kx plus 1 if x less than or equal to pi. So limit as extending to pi to the left of fx will be limit as extending to pi of kx plus 1. So substituting for pi, we get it as k pi plus 1. Limit as extending to pi to the right of fx will be limit as extending to pi of cos x, because pi to the right means x greater than pi, and when x greater than pi, fx is cos x. So when you substitute the limit, you get cos pi is minus 1. And since f is continuous at pi, the left-hand limit as extending to pi to the left of fx will be equal to the right-hand limit, that is limit as extending to pi to the right of fx. So I have k pi plus 1 equal to minus 1, or k pi is minus 2, or k is minus 2 by pi. Coming to question 5, fx is 3ax plus b if x greater than 1, equal to 11 if x equal to 1, equal to 5ax minus 2b if x is greater than 1. F is continuous at x equal to 1. Find a and b. So limit as extending to 1 to the right of fx will be limit as extending to 1 of 3ax plus b. because fx is 3ax plus b if x greater than 1. So when I substitute, I get it as 3a plus b. Limit as extending to 1 to the left of fx will be limit as extending to 1. 1 to the left means x less than 1. So fx is 5ax minus 2b. So substituting x equal to 1, you get 5a minus 2b. Now f is given to be continuous at x equal to 1. So the left hand limit equal to the right hand limit equal to f of 1. But we have the left hand limit is f of a minus 2b and the right hand limit is 3a plus b. And f of 1 is 11. So we get 5a minus 2b is 11, 3a plus b is 11 because left hand limit equal to right hand limit. Solving simultaneously, you get a is 3 and b is 2. Question 6. Fx equal to x sine 1 by x when x not equal to 0 when x equal to 0. Examine for continuity at x equal to 0. Now this is an important problem. So we have fx equal to x sine 1 by x when x not equal to 0. So note the method here. We take mod fx is mod x sine 1 by x. This is less than or equal to mod x because mod sine theta is less than 1. So mod sine 1 by x will be less than or equal to 1. So we have limit as extending to 0 of mod fx less than or equal to limit as extending to 0 of mod x, and this is 0 when you substitute. And mod x is greater than or equal to 0. So I have 0 less than or equal to limit as extending to 0 of mod fx less than or equal to 0. So fx is sandwiched between 0 and 0, the limit. So I have limit as extending to 0 of fx equal to 0. And we have f of 0 is 0 because fx is 0 when x equal to 0. So I have limit is extending to 0 of fx equal to f of 0. That means f is continuous at x equal to 0. So mark this problem because it's a slightly different problem and it follows a different approach. So we have practiced a few more problems on continuity. And the only way to learn mathematics is to do mathematics. So you have to take a pen and paper and practice each slide, each line along with me. You may have to practice it more than once to master the topic. Thank you.